Ladies and gentlemen, good evening. Tonight we're going to look at Golang. It's a language from Google, and it's actually, thank you Slave Zero for pointing me in this direction. There's a person in the community. And Golang, it's actually a very simple language, and it's used by Google. That's the biggest implementation. I think I've not heard about a lot of them. Actually, I've not heard about any implementations in my everyday work life. But let us get right to it. I'll just give you an introduction here today, and we'll look at some code as usual, because that's the most fun part. So first of all, what is it right here? It's a statical type compiled programming language. It's actually being compiled to all operating systems. So that means that actually through the years, they actually, in the beginning, it was just a couple of operating systems that were supported, like Linux and Mac OS, and then but then they continued adding all the systems. So now I think that most systems you could come up with is actually supported, like Windows is also supported, Mac OS, Android, iOS, so Linux. And the way it works is actually that it's being compiled to the operating system that it needs to run on. So that means that if you run something like this, go build my app, then it knows that because this is for Windows, then it would actually create an executable.exe file. So that is a language. But why we actually use it at all? The reason why we could use it is actually because it's very, very efficient. It can spin up a lot more threads, I think, than a Java program could. I've heard that it should be able to run on millions of threads without any problem. And I also saw this Reddit comment right here where they're actually talking about that it's very lightweight. It can run. Of course, this stands on challenge, but I know that my Java programs cannot spin up a million threads. Then they would run out of memory because there's an overhead by creating a new thread. And that is actually also why in Java we are looking at reactive programming instead, where we reuse the same thread. And if you're using Kotlin Ktor, then the same threads are also being used for coroutines instead. But enough about that now. Today it's about Kotlin, not Kotlin. Today it's about Go. Sorry. We'll just get started right here. If you want to learn Golang, it is quite easy to get started with, because you just go to tour.golang.org, and then you actually get these nice tutorials right here. I'll go through the first tutorial with you tonight, and then we'll go through the next tutorial another evening. So I think I'll make one evening one video per tutorial right now. First of all, we have the usual hello world program. So what should we write right here? My microphone just needs to be adjusted a bit right here. Yes. So that now I can type. I cannot type yet. Let me just put it over here. Sorry. And let's get started. Hi community. I am writing Golang. And they have something with percentage %s, just like we have with Java. So then we can use a variable right here, like Mike, and then I can set the value var Mike, and then the type. I can write string right here equals testing 1 2 3. And then we can press the run button in the right corner right here. And for each page, each exercise on the file string, needs to be with the lowercase maybe. I'm quite new to this, so bear with me when I make mistakes. Hi community, I'm writing Golang, testing 1 2 3. Okay, let me just jump to the left corner. It will be a bit easier for you to watch. So that is the first one. And then you just press paste down, and then you get the next. Then press down. We get the next. We get next again. Here, press down. And the Go playground. So now we're at the playground. That's good. This is a playground. Let us just press run. Then we get the time.no. As you can see, just along with Java, we have just as we do with Java, we have some imports in the top, and many other languages, of course, when you need to import your libraries that you want to use. And then we have a package also. So we have a package right here, and func. This is a method. So this will be a public static void main. Instead, in Java here it's a func main, so it's a bit more. It feels a bit more lightweight, right? Maybe a bit like JavaScript. I don't know. Then we have time.now. Then it prints out time.now. If we run this, we already ran it. Then we can see the time is now, blah, 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 11 o'clock plus 0 UTC. Thank you for that information. We'll go back, continue the next tour, packages. So these are packages. My favorite number is, and then a random number. So right now here we use the rand from the math package right here. My favorite number is 1. Let us just run again. So we can get a random number between 1 and 10. Why is it 1 all the time? That's incredible. I think the random number generator is stuck. 81. Okay, maybe I was just lucky to get 1 so many times. I think I was just lucky. And now it gets 81 all the time. Yeah, there's something fishy with the random number generator, but that's okay. That should not separate us. So let me go. Let me take next one. So we have some imports right here. They show that we actually have we can import math, and we can get the square root of 7, and then we can use again the percentage. It's just like in Java string format, I think actually. So we have the percentage G right there. So here we have the number. And next one again, so that was just the square root. Exported names. Yeah, this to fix. I've actually already fixed the error. That's why it says pi with the capital P. And that is because they are. Yeah, it needs to be with the, you can actually see that there's a rule right here. Pizza and pie do not start with capital letters, so they are not exported. When importing a package, you can refer only to its exported names. Any unexported names are not accessible from the outside package. That's why we need to write pi with a capital P right here. And it actually started with a lowercase pi, and then you had to fix it. But I already did that just before, so that's why I could actually remember that. Pretty cool. Let me look at this function. Okay, this is how to have functions right here, and we can return multiple values. This is awesome. If you're used to Java, then you would have to use the tuple instead. Here we have 55. Here it actually just returns 1. It only returns 1 value right here. So let us just take that scenario right there. It is the next scenario where we return multiple values, isn't it? Functions continued. What are we showing here? We're adding 2 numbers, and then we're printing it out. We just show the multiple results. This is pretty cool, because here we actually say that we are returning. This function right here returns 2 values. I think that is really awesome. What we just need to remember is we just need to say A, comma B, and then we need to write colon equal to. If you don't write colon, then it would not work. And then we call the function swap what's this community, and then what it actually does is it just it swaps the values. You can actually see that it returns y before x. So let's just run that. Community, what's this? And actually, again, it was me who I will press reset, because it was actually me who made this. It was actually hello world just before. Not that there's the big change. So hello world, hello. Yes, great. Named return values. Yes, look what they're doing now. They're actually naming the return values like this, and then they're making an empty return right here. So that means that let me just zoom in a little bit. So that means that we're actually not returning. Anything. We're setting those named values right here instead, and then we're returning them right there. And let me also just reset this, because this was actually just like that. 7 and 10, we're printing out those values right there. But what we could actually do is we could actually say A, comma B, just like we did before, and then the colon and equals, and then the splits, and then the number 20 or something like that. Could also choose 17 again, just for fun. And then we can print out, I'm going to write print line, value 1, value, and then we write percentage S, that's just a string representation, another value, percentage S, like this, and then we have A, comma B. Let's see if this runs. Here we have them, 8, 12. They're actually just being printed afterwards, so they were not being replaced right there. Maybe there's something, maybe it's a bit different. Actually, I don't know. It does matter, but what matters is that we get the 2 values. We got the 2 values out right here, A and B, and we get those from the function called split. And of course, I could name this function whatever I want to name it, and we're importing the FMT package all the time, so we can print out to the console. Very normal, very common. Then we have the variables. Right now you can actually see here we have C, Python, Java, and they are all bool because we give the type in the end and we start with just saying that it's a variable like this. You can also inferred variables is also possible. So that means that if I create a var mic equals to blah blah like this, then I can also print mic like this. Let's just do that. First of all, we get 0 because the integer is not set, and we have default values right here. So we need to get used to that. It's not like it's an object in Java where we set it, and then it's of course the primitives or the native types in Java. Of course, they are also not objects, but if you in Java you could have a boolean with a capital B, right, and then it would be an object, and then that would be null by default. Right here, it's actually false. So we have there's the integer is 0 right here. The int is 0, and then we have 0, and then we have false, and then blah blah, because I set it to blah blah. That means this would be inferred as a string per default. We can also print out the types, actually, and this is what this comes here, I think. Yeah, I think the types comes a bit later, so I will just continue. If it doesn't, then I will make an example where we can print out types that is percentage T in the string. So here we have print line, then we have blah blah with initializers, we have our variables again, C, Python, Java. And then we can set it to stuff. Let's say that these are different types. Again, we can just use one line. We don't need to have multiple lines right here. So we set the C to true, we set the Python to false, we set the Java to the string as a string, and then let us just run it and see what it actually gives us. 1, 2, true, false, no. Awesome, right? Let us continue. Okay, this is actually me. Yeah, I was actually just dividing. Some numbers right here. I was playing around with some floats because it's called float 64 right here. I did not know that, so of course I could also leave out the type. If you do not have a dot a decimal right here, then it would think it was an integer instead, a whole number, and that's what I did in the beginning, and you could not divide it and get a correct answer. So we were actually discussing how many percentage of the Spring test do you need to have correct in order to pass it, and it was 38 questions out of 50 questions, and that's why I typed this in right here. So then I calculated, and it was 76% of the Spring Boot. Is it the certificate? I think it's a certificate. Yeah, you need to have 76% of the answers correct. Let me just reset it. This was the original example. Of course, it's way different than what I was just typing there. We have some variables right here. I and j, the integers, we set them to 1 and 2. Yes, now we understand that. K equals 3. Okay, so now this is short variable declaration instead. So we have k equals 3. We are not, where's the var? We don't have any var in front of it. Okay. That is pretty cool. Then we have C, Python, Java. And then again we say true, false, no. That means we do not need to write var in front. So this is the short version of it. It's much faster to write, of course. 1, 2, 3, true, false, no. It runs as it should. Cool. Basic types. Yeah, we have all the basic types I actually mentioned over here. Float 32, float 64. Some complex values. We have byte. We have the integer, unsigned integer that cannot be negative. We have the string. We have the boolean. We have enough of types. Yes, thank you for all those types. And then here we have some more Spring formatting here, right here, which I'm not as good at. Which I'm not good at. I have to look up the documentation. I have to format a string. So 0 for numeric. This is the default values. 0 for numeric types, false for booleans, and an empty string for strings. Yes. Let us run the program. Then we get an empty string right here. So that was the string. Type conversions. Here we need to use the type actually, and then use brackets around it. That is how we cast from one type to another type. We need to do that, or else we'll get an error. There's not much to say about that. Type inference. Yes, this is a let us try to see what happens right here. Can I see here the default type is actually float 64. maybe if you use the decimal value as I do right here. And we have not written var in front. If we did that, then we could have done this instead, of course. Like this. Var is of type float 64. If I change this to an integer, then it says v is of type, and then it says %t. %t, that's the type, yeah. So and then it gives the type of this variable right here. It's int right now. You can also say, oh, did I just close it? No, here it is. Okay, I have 2 fat fingers, that's why. So let me just check right here and then remove that. So I'll just say hello, and then run again. So now it should be a string. Yes, now the type is a string. That is pretty cool. That is pretty cool that it can just infer the types. Thank you very much for that feature. So here we have some constants. We have a pi. We can just write const like this. And this is, again, this is for the, I think this is package scoped actually. Because we put it up here. There are different scopes that are used right here. So here we have const pi equals to 3.14. Let's just try to run the program, see what happens right here. Happy Pi Day. Yes, go. Yes. And then we continue. Numeric constants. Needn't speak to try to bring. Yeah. Here we have some numeric constants right here. Need float. Need const to create a huge number by shifting. Yeah, then shifts. Let us not look at that. That's a bit boring. Congratulations, you finished this lesson. So that was the lesson. I'll create another video for next lesson because of course there's a lot of the other thing in the language. Like there's loops, there are if sentences, etc. We have all the logic. So we're going to look at that another evening. I will try to keep these videos short, even though it's difficult for me because suddenly I'm just talking about some stuff. Thank you very much for watching. Have a great evening, and I hope to see you again soon. Bye bye.